Riley. I'm going to be presenting sprint number 22. So the question asks, compute the number of base 10 integers that are less than 1,296 base 10, whose base 6 representation have digits that sum to 6. So I think the way that we can think about this is, so firstly, I think the number 1,296 in base 10 is, it's you might notice that this is 6 to the fourth. So I'll just write this. So this means that for these numbers that we want to look at, they're going to have at most 4 digits because like 6 to the fourth would have 5 digits in base 6. So I think we can just start with the simplest case. So if we just have one digit, we can write this as the letter A, or I guess I'll just write the digits as letters. So if we just have A, we would want it to sum to 6. All the digits would sum to 6, but since you just have one letter, it would be 6. But in base 6, you can't have the number 6 as a digit since you can only have the digits from 0 to 5. So we wouldn't have any cases for just one letter. Sorry, for a number with just one digit. So I think for the counting though, I'm just going to write this as 1 minus 1, and this might be kind of confusing, but yeah, it might be a little bit more clear why I'm writing 1 minus 1 for these next few numbers. So so just for the next case, so we would have 2 digits, so I'll write them as AB. And so we would want the sum of A and B to be 6. And there's one kind of caveat, which is that because this number has 2 digits, the first digit it can't be 0, it has to be 1 through 5. And so we always have a sum where both of the digits are non-negative, except that it's just that A has to be positive. So one kind of fix we can make is we can subtract 1 from A. And in this case, just for the sake of time, I'll just add like a little prime to A, and then I'll subtract 1 from 6, so that's 5. And now we have A prime plus B is equal to 5, and A prime and B are both just non-negative, so A prime can also be 0 in this case. And so you can use like sticks and stones here. Yeah, so if you might be familiar with that, the way you can count this is you have one divider and you have, I guess, 5 stones. So this would be 5 plus 1, which is 6, and then choose 1. And there's just one case that we have to like kind of keep watch for, is that B is just its normal number, but since we subtracted 1 to get A prime can be in this case, from 0 to 5. It's just that we have to keep in mind that A prime can also be 5. So if A prime is 5, then that means that A is going to be 6. And if A is 6, then our number would be like 6, 0, our original number would be 6, 0. But we can't have that, so we just have to subtract off one case. And then, so now moving on to the case for 3 digits. This is A, B, C. And so we have the same thing, but I'm just going to write the prime over A. So I'm subtracting 1 from A. And then this full sum will be A prime plus B plus C is 6 minus 1 because I subtracted 1 from A. So that's 5 again. And using the same idea, sticks and stones, we'll have so 5 stones, I guess, and we have 2 dividers, so that's 7. Choose 2. And once again, we have this case where if A prime is 5 and B and C are 0, then that corresponds to just one case that we can't have, which is 6, 0, 0. So you have to subtract off 1. And then finally, A, B, C, D, we just have 4 total digits. Sorry for my bad handwriting. And we have this full sum, A prime plus B plus C plus D. And A prime is A minus 1, so this is 6 minus 1, so that's 5. And once again, using sticks and stones, all of our numbers are now non-negative. So you can write this as you have, once again, 5 stones, and you have 3 dividers, so that's 8. 8, choose 3. And we just have that one case where A prime can be 5, and in that case, B, C, and D would be all 0. That would just correspond to the number 6, 0, 0, 0 for A, B, C, D, but we can't have that, so we just subtract 1. And then these are all of our cases, so we can just sum them up. So we'll have, I can write it out. So 1 plus I'm going to write the positive terms first in all these sums and then just subtract off the total. So 1 plus 6 choose 1 plus 7 choose 2 plus 8 choose 3. And then we had 4 cases in total, and in each case we had to subtract off one number, so just subtract off 4. And then we can just calculate this. So we have 1 plus 6 choose 1, so that's 6. So 1 plus 6 is 7. And then we have 7 choose 2, so that's 7 times 6 divided by 2, so that's 21. And so that whole sum, actually, I'll just simplify that, is 28. And then add 8 choose 3, so that's 8 times 7 times 6 divided by 6, so that's 8 times 7, so that's 56. And 56 plus 28 is going to be 84. So I'll just simplify that sum, sorry. And then finally, we're subtracting out 4. So our final answer is going to be 80. I'll quickly box this. Great, thank you.
Hey, this is Tim. Hope you're enjoying our videos. If so, you know what to do: like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.